Hello, and welcome to tutorial, tutorial number 3 or video number 3 of our GUNPLA series, where we finally will start modeling. And I will begin modeling immediately, I guess. I'll just create a new layer here, or I'm just going to call it model. I don't know, model. So in this tutorial, we're going to create a backpack, or rather in this tutorial series, we're going to create a backpack for our robot, which we've 3D scanned and kind of cleaned up in our previous videos. And this backpack is going to be 3D printed and placed on the actual GUNPLA model that I have. So to start things off, I'm just beginning with a sphere which represents the center point where my backpack core, let's call it a core, where it's going to be located, and I'll just move it as close as possible to the model. Something like that, maybe even closer, something like that. Yeah, that seems good. And let me actually lock the base mesh model so that I don't accidentally select it. I'll begin thinking about what kind of a form I want to get out of here. So if this is the core, I want to have a few guys that are sticking out from this backpack. Let's say it like that. So I want a few guys that would be sticking out. How do we do that? Well, I guess first thing would be to actually create one and then place it in the correct position. And for that, we need to decide what kind of design we're going to have. First of all, very simple decisions. Is it a rectangular form, or is it a curvilinear, let's say a cylindrical form? For this particular model, since it does have quite a few curvilinear shapes and these kind of bendy shapes, I'm thinking of doing a cylindrical form. I'll just create a cylinder at 0, and I will give it some sort of a width or some sort of a radius. So when thinking about what kind of radius to give, always consider the fact that it's going to be, in this case, it's going to be 3D printed. So you always are kind of locked by the fabrication method that you're going to use. And I'm going to be using an FDM 3D printer, meaning that everything that's going to be smaller than 1.2 millimeters is going to start losing quality quite a bit. So I want my smallest details to be 1.2 millimeters. So I guess we can go for, let's say 4 millimeters for the radius. So that means it's 8 millimeters in total. And then what's the height? Let's go for I'll start off with 70 millimeters, which is 7 centimeters, to just see how the proportion looks like. So I have that cylinder here, placed here, and let me I'll just make a quick copy of it and kind of rotate it and place it where I'm thinking of having it, somewhere here. Yeah, so the proportion seems to be kind of okay, I think. 7 centimeters. Yeah, sure. Let's have it like that. So I'll hide the GUNPLA model and start working on this guy here. So before I place it in the correct position, I will begin by making a few adjustments to it. Well, first of all, these edges here are kind of meh. So I'll fillet them, fillet edge, and we did use this 4mm radius, so I guess I will use like 3mm for the top and the bottom edge. So fillet edge, what it's going to do, it's going to round off the edges that I have, so I have this kind of a more like a pill type of a situation going on here, right? And then let me actually move this in place, and we'll continue working from there on out. So there's going to be an intersection going on here, which I'll need to take care of, but that's a bit later. For now, let's just see. And we will need to have smaller versions of this guy. So should I first make a bunch of copies and then work with all of them, or should I first detail this out? Well, okay, let's think less and do more. So first things first, I'm going to fix the intersection here. So to do that, let me actually move this guy. Is there a center point? Yeah, from center point to 0, like that. And I'll just hide the sphere for now. And let me work with it in top view. So in 2D, I want to draw out some sort of a form. And let's think about the form for a bit. First of all, it's going to be orthographic, meaning that it's going to be 90 degrees. And actually, I do have snapping set to 45 degrees as well. But I want to have snapping set to every 30 degrees. So where I have my ortho here in the bottom, ortho snap turned on, I can right click on it and choose set ortho angle here. And I'll just type in 30. So now it's going to snap every 30 degrees, and I believe it's going to help me in my journey trying to make this all work. So I'm just drawing out, let's say, 6mm up, and then, I don't know, something like this, and perhaps something like that, and then, nope, undo, something like this, that, then this goes down a bit more, like that, and like that. Yeah, this should do the trick. Okay. And then the way I close it, I don't think it matters, or does it? Let's think again. Perhaps it doesn't matter, we'll see. So I have this kind of a curve drawn out, or polyline drawn out. On it, I'll just use planar SRF, planar surface. No faces were made, cursor must be closed or planar, meaning that I accidentally, here, I snapped to the wrong point. But that's fine, I can just use project to C-plane tool, which will move all of these control points to my XY plane. Delete input objects, yes. And as you can see, everything, like all of these points were moved to 0, 0, 0, or either XY plane, which means the curve is flat now, and I can use planar SRF on it and delete the curve. So I have this blade here. Should I mirror it? Sure, but first, before we mirror it, I'll just use offset surface, and I'll offset it to both sides. So I'll choose both sides on it here. And distance of offset, as I mentioned before, I can't have a detail that's smaller than 1.2 millimeters. Or thicknesses that are smaller than 1.2 millimeters. So here I'll use 1.6. A bulky boy. Wait, it's 1.6 on to both sides. So I can use 0.8 because it offsets by 0.8 to both sides. So then I have 1.6 here. Okay, so we have this going on. That's great. And now let me, actually, yeah, sure. I'll just mirror it around the 0 point, holding down the shift key, or no, without holding down the shift key, but with ortho on, I'll mirror it to the other side, just like that. And now we can use Boolean union and union these guys together into one big happy family. I don't really like how this edge turned out, so I'm thinking of cleaning it up. So I Control Z the Boolean union, and I'll just move this a little bit back, a little bit further back, like this, and I'll Boolean union first these two parts together, and I'll just use merge all faces to just clean it up a little bit. And now I'll use Boolean union between the cylinder and this plate here. Okay, so we have this guy going on. That's good. But now I want to cut away a part of like the bottom part of this form here, and for that I'll just use a box. Oops. I'll just use a box, nothing fancy. Like that, like that, like that. There we go. And I don't really care about the dimensions in this case, so I will just kind of wing it by eye. Something like that. And maybe the cut is actually not 90 degrees, but rather 45. So I'll just use solid PT on and move these points to something like so. So for a box, only solid PT on will work, like irregular points on will not work for a box, or any polysurface for that matter. Boolean difference to cut away, and now we have this form. So I already used, what was it? How is it called? God damn it. Merge all faces. I already used it, but here it's a good place where I can show how it works. So this edge right here happened because of all of the booleans that I did, right? This rectangle here, and I can get rid of it by selecting the polysurface and typing in merge all faces, like that. Now it's cleaned up, right? Okay, let me show to see the sphere, and let's see how we can assemble this form on top of the sphere. So actually I'm just going to, holding down the Alt key and moving it with a gumball, I'll just make a copy like so. I'll move it, I'll rotate it like that, and how do we do this? Perhaps we can use the right side. Yeah, like that. Shade that view. So I'll no, that's wrong. We need to look at the left side. Yeah, like that. And just find a good position for this object. Something like this. Okay. And now it's going to be here. And as you can see, the intersection is kind of wonky. It's kind of weird. So I need to clean up, or not clean up, but I need to fix that intersection. Well, first of all, this guy needs to move in, and let's say it's rotated 30 degrees outwards. So it's actually doing something like this. And that's not too bad. And just, I know I'm not being accurate with this approach, but what can you do? Okay, so that seems to be kind of okay. Let me mirror around 0. 0. There we go. So it's gonna look like that. How does the model look like? Like that. So these would be just sticking out like so. Maybe that's not too bad. Okay, I'm gonna say that is absolutely fine, and or rather, nah. Maybe let's have them stick out properly. So I'm going to turn off the model, delete one of them, and kind of rotate it a bit more, a bit better. Which we can use, for instance, this edge to rotate around so that we are a bit more precise in our rotation. So rotate 3D to do that. It will ask us for rotation axis, which is going to be this edge right here, like that. And I'll say, yeah, give me this guy and just rotate downwards. Do we choose a degree? Yeah, we should choose a degree. So I'll just type in 30, I'll type in -30 to rotate downwards. And now there's another set of positioning that needs to take place. That seems to be good. That's a bit problematic. I'm just making sure that I don't have issues like these in my model. So like that. Maybe something like this. Maybe a little bit in. So this touches here perfectly. This touches here perfectly. Yeah, it seems to be good. Okay. And then I can mirror 0. There we go. So now there's an intersection going on, but I can fix it quite easily by using Boolean difference, select polysurfaces to subtract from. So I'm going to cut away from the sphere, enter, subtract with this guy and this guy, delete input, no, because I want to keep those two guys. So now you can see that this sphere was like everything, all of the intersections were cut away, and the only parts that are left that I don't need are these 4 like polysurfaces, which I can just delete. Okay, so now we have this going on. If I were to move this away, you can see the sphere was, was cut. That is good. Let's see how it looks like with the robot. That's fine. There's going to be an intersection there, so I need to take all 3 of these and move them back a bit so that there's, and maybe up a bit, even more, so that there's no intersection. Can I select this whole thing and just slightly rotate it like so? Yeah, it seems to be okay. There's a slight intersection there, I know, but I believe this is fine. We can work this out by trimming and so on. Okay, so we have this going on. And now the sphere is a bit too high, so actually I'm just going to kind of move it back. So we have, what we're doing right now is called a block out, meaning it doesn't need to be pretty, but it needs to have a correct proportion. We will fix all of the issues throughout this project, and we will make all of this 3D printable. Don't you worry. Okay, so we have, will I reuse these? No, I won't. I will create a new one. So we have two of these bad boys here. I will want a few more, but before we do that, I will kind of create a few panels, let's say it like that, on the sphere itself. So it's not a panel. That's a bad way to say it. I will be creating a few details on the sphere. So the main detail that I want is I want something happening in the back of the sphere. So I will just select it and I'll go to left view. can we create a circle around the center point? That's not the center point. Around, hello, the center point of the sphere, like so. Just want a circle, like that. That's perfect. I'll just move it here. And I want to take the circle that I've created, right? And use project, not to C-plane, but just project. And it will ask me what am I projecting it onto. I'll specify that it's, oh, actually first I need to go to the correct view, so that's going to be the left view. And I will specify that it's this sphere here, and then hit enter. So you can see it takes this curve here and just projects it to the sphere on both sides. Unfortunately, I just need it here. But now I can use this projected curve to split, select object to split. So I split this poly surface with this curve. Hello, split with this curve. Enter. There we go. And now I end up with, delete that. I end up with a hole here that I can work with. Okay, so how do we do this? I can offset this curve inwards, and that's gonna be like a 0.6 millimeters. Loft, or I can just use planar SRF. Planar surface, we have it. We have a ring there. I can take this curve, extrude curve. So I'll extrude it inwards, and I'll make sure that solid is set to no. So I just extrude it inwards like that. And then I will duplicate edge. I will get that curve with duplicate edge. I will offset that curve inwards again by same amount, I guess. Loft or planar surface, doesn't matter which one you use. And this one might, maybe I will extrude. And let me actually extrude it just a tiny bit, 0.4, more, 0.8, like that. Duplicate edge again, get that curve, and maybe we just, do we do planar surface on it? I will come back to this and make a few more alterations, but for now this is like good enough. So now I'm selecting everything and unselecting the joined B-rep or poly surface and hitting delete. So I'm left with this guy here. And actually let's get rid of these sharp edges here. So I'll just use chamfer edge, and I'll say that chamfer distance is like 0.2 millimeters or 0.4 maybe. So I'll just, and as you can see, chamfer is very, like it's quite close to behaving the way fillet behaves. Nah, I'll keep that as it is. Let's look at it with Arctic view turned on. Yeah, that seems good. So chamfer behaves in a very similar way how fillet does. It's just that it doesn't round it off. It makes these kind of sharp cuts, which I also quite enjoy. So we have some detailing going on here, and we'll kind of continue on working with these two blades later on. Actually, I can just delete one of them for now. All right, so now I want to have a few more of these cylinders. I will create a cylinder, and last time we used 4 millimeters. This is going to be a thinner one, so it's going to be a 3 millimeter cylinder, and same length though, 70 millimeters. And I will just, again, fillet edge. This time I will do 2 millimeters for filleting to get that capsule look. And this one I just want to stick out from this object here, just like that. Maybe it can go up. Yeah, let's make it go up. So now it's horizontal. Let me turn on the ortho and just rotate it so that we kind of keep that 30 millimeter 30 degree input. Okay, so I have that sticking out and it's not looking great. Maybe it can do something like this. Move it down a bit. I think that's fine. Okay, and now there's that intersection that we need to fix. Actually, let me quickly see if it's fine. I will mirror it to the other side. That's a wrong mirror. Mirror, enter, 0, enter, click. We have it mirrored. Let's see the model. We have it sticking out like that, which is kind of okay, but we will need more. We will definitely need more like these. So how do we fix it? Tell you what I'm going to do is I will take one of these. So for now I'll just select this guy here, and actually let me just hide that instead. There's an intersection going on and I want that curve. Maybe, do I? Perhaps I do. Yes, I do. I want that curve, so I will say, or do I? Sorry. I know I'm blabbing, I just need to figure it out. No, I will instead say, give me this edge, so duplicate edge. Give me this edge, and let's move that edge towards, come on, just, I want to move it along this the cylinder here, so I'll move it from the center point that is here to the center point, just I'm fighting it. Perpendicular snap off. Now give me the center point. There we go. To this center point here, and I'll move it by 50. Let's do 45 millimeters, like that. So now I'm completely sure that this curve is definitely on this poly surface. And what I can do with it is I can take this curve and offset it by, yeah, sure, 0.6 is fine. No, actually it's not. Offset 1.2, like that, so that it's a thicker boy. And take this curve and extrude it, extrude curve. And I will explain why I'm doing it in just a bit. But basically, I need this this object right here that I have, this sphere, to, in the future, I need to be able to just place these cylinders into the sphere, kind of cram them in there. And for that, I need to do this. So I have this curve here, and I have this cylinder here. So let's think about this for a bit. How do we make the sphere be able to take in these cylinders? Well, first of all, we need to have some sort of some sort of a system, which might as well be something like this. Yeah, something like this. So I need this cylinder. I'll just cap it. Select the cylinder, type in capped so that it's kind of a closed form. I need this cylinder. And before I do anything else, I will make a copy of this guy here. I will just make a copy of it so that if I kind of screw it up, I have a original copy. And also I've noticed that I forgot to join in this detail portion with the rest of the sphere, so I'll do that. I'll select both of these geometries and type in join. So now it's a single closed poly surface. And now let's do some cutting. First of all, the cylinder here. Boolean difference. I want to cut away everything that I don't need from the cylinder. I only want that edge there. So Boolean difference with this sphere, enter. I end up with this portion of the cylinder here and this unnecessary portion here, which I can delete. So I have this cylinder here. That's good. And now I have this pill thingy going on. Can I actually gumball align to object? Yeah, it doesn't care, does it? Align to object. Okay, sure. So I'll just move this guy out a bit to something like so, because this is how far I expect this is going to stick in. Or should we do a bit more? Move something like this. Yeah, sure. Let's do it like that. And actually, did I rush it too much? Yeah, Control Z a bunch of times. So before I did the Boolean difference, I'm going to actually select this whole thing and type in group. And I want to make a copy of it. So I want to kind of just copy it up, turn on my GUNPLA mesh to see the proportion, and I want to make sure that that everything kind of fits properly. So it's doing that now, which I think is absolutely fine. And where is the middle point? Are we beyond the middle axis? Oh yeah, we're intersecting with the middle axis, so I need to actually move it like that. Move it like so. And if I mirror it, 0, it's gonna look like that. I don't like those two at all, so instead of doing that, I will just I'll position this to 0 so that it's centered at 0, and I'll move it in the front view like so. I'll just make sure that it's right here. So it's going to be right at the middle, sticking out like so. Yeah, I think that's better. This seam is really messing me up, but what can you do? Okay, so we have that going on, and now I'll mirror this guy. 0, just like that. Okay. Let's show selected. Let's see how it looks like with all geometries that we've already created. Looks pretty cool. I'm not sure about this one though. maybe it's a bit too much. You have that. Maybe this guy can be, what if we do it in front? What if we rotate it and it's kind of looking down even more? And that's pretty cool. Sure. So I will do it this way. So as you can see, it's right now I'm just kind of designing it as I go. So now we can come back to here and ungroup all of these. Ungroup, Boolean difference. Boolean difference, and I'll just carve away from these cylinders. Enter with this sphere. Come on. Boolean difference from this, and this. Enter with this sphere. Enter. There we go. And I'll just get rid of the necessary stuff that I have here. And I'll just make sure that these cylinders don't intersect as they go into the sphere. So I'll just move it like so. Here. And for here, do I want to have a perfect symmetry, or can I have it a bit more wonky? Yeah, maybe I want to break the symmetry a little bit, or nah, it's too early to start breaking symmetry. So I'll just do 8 millimeters. I'm just basically moving them out by 8 millimeters outwards. So I have something like that going on. Okay, and now you might think that I can just do Boolean difference, right? And kind of, well, first of all, I need to connect everything here into one big happy family, and for that I can use Boolean union. So now this whole thing is a single polysurface. And you might think that I just use Boolean difference and kind of create a hole there, but not really. I will take these three guys, and actually now I know that it's gonna work, so I don't need the additional one. I'll take these three guys and I'll call these, create a new layer and call it cylinders, and make it red or whatever, and just copy objects to layers. So I'm copying these guys into that cylinders layer, and I'll just hide it. So now I have the original copies, and with these I will be using Boolean difference to carve out, but I will also be scaling them up in all the directions by 1 point, let's say 0.5 by 5%. Yeah, 1.05 is 5%. So I'm just going to scale everything up by 5%. And the reason why I do it is because for my printer, that's kind of the tolerance that I need to do for things to start fitting properly. And you might have a better machine than I do for 3D printing. So you might not need to scale it up. Boolean difference. Select these guys. This time I will delete the input. Yes, enter. And I have holes here. Cell CRV, select curves, delete the curves, don't need them anymore. Okay. So we have this going on. And also the model, and show selected, also these blades here. So blades wise, I need to have some form of locking mechanism to be able to lock these two guys in place. And I'm thinking of doing something quite simple. I will just duplicate edge. I'll just get that little curve there, kind of scale it up, like so. And I will pipe it. I'll type in pipe, and I'll say that the radius is like, sure, 1 millimeter. That's fine. Is it fine though? No. Let's do radius of 2.5 millimeters. Like that. Perfect. Now I'll just scale it down. Move it from its endpoint. So you always need to figure out, you always need to figure out what you're going to snap to kind of continue using these, like to have everything aligned. So I always have the midpoint snap turned on because that really helps me align things. So I have that going on. I'll just move it along, I guess, this edge here, somewhere here. Let me hide this real quick to see what's going on. Move this out. Something like this. Yeah, I think that's gonna be fine. Tick tick. Yeah, for now I'm gonna keep it as it is, like so. Show selected. There's our guy here, and I'll just use. How do we do this? Is this an interesting? Can we work with this? Yeah, we can. We can make this cool. Okay, so I will join these two guys up with Boolean union. Like that. And I'll kind of just mirror it once I'm done with this. And also, since this guy, let me isolate, this guy now has this thingy here, duplicate, or rather not duplicate edge, but chamfer edge. Next chamfer distance 0.4, sure. And here. So this guy has this edge here now. And if I show the sphere as well, the sphere needs to have a hole there to kind of have that pin go in. So I'll just use Boolean difference, subtract from the sphere, enter, delete input no. This time because I want to keep what I'm going to be cutting with, and hit enter again. Let me double check how it looks like. Ooh. That means it goes in too deep because it's intersecting here. How can we fix that? Shit. Okay. Show selected. No, not show selected. Isolate. I will just take these points and move them. Like basically just make this pin smaller. So I'll select the whole shape. Turn on solid points on. Select those 2 points, not the third one, not this one, just these 2 points, and move them towards this base point here. And I'll move them by, let's say 1 millimeter inwards. I think that should be enough. Show selected again. And we try again. Boolean difference from here with here. Hide that guy. Ah, shit, still messing up. Do we care? Basically, the cylinder will not go in completely here, but maybe we don't care. Or rather, what we can do. Okay, let's fix this. Isolate. What we can do is we can just make that cylindrical hole a little bit smaller. So I will type in solid points on, make sure that I'm in wireframe view. And basically if I just take these 2 points here and move them, let's say 1 millimeter back, like so. Can we do one more? So I'm moving them along this edge because I want to keep everything aligned, of course. Let's say 1 more millimeter. So 2 millimeters in total. And same thing for this guy here. I'll just select these 2 points and move them back by 2 millimeters. Just like that. And what about this guy? Yeah, I guess if we're moving everything, we might as well move this guy as well. So move it 2 millimeters. And then we try again. Show selected. And this guy here. Shaded. And then Boolean difference from here with this one. Hide. Finally. Okay, that's good. That means it's fine. So now I'm just going to mirror this to the opposite side, like that. Boolean difference. Cut it off, hide, and we have something like this going on, which is okay. It's still not looking great whatsoever, but it's starting to get there. So now let me actually detail this part a little bit because it's way too ugly. So I'll just detail one and then mirror it to the other side. Can I extract surface? I'll just use extract surface to get rid of that single surface there. Duplicate edge, or rather, before I extract surface, I will chamfer edge. I will chamfer this guy. Hello? Why can't I? Chamfer edge. Creased surface. That's a new one. Never heard of that one before. Okay, sure. Then we don't chamfer. We just use the extract surface, delete, duplicate edge, offset inwards by 0.6, loft, that, duplicate edge again, extrude curve. Can we extrude it quite deep? Yes, we can. Duplicate edge here, super, and for now I'll just use planar surface to just cap it. Okay, join it up. So now it's a single joint polysurface. Mirror it to the other side, 0, just like that. These two guys are intersecting. I hate that. So I want to fix it. How do we fix it? Can we make a cut here? Yeah, sure. Let's make a cut. So I will just I'll just draw a line along this edge. I just need an alignment line like that. Move it to this part here. So it's going to be like that. Duplicate edge. Move it to perhaps somewhere here. Oops, it snapped to the other edge, so I'll just move it back like so. So we will have something like this, like that. Maybe then we can kind of repeat it, copy, like that. Yeah, seems to be okay. So I have 1, 2, 3 lines, and I'll just use duplicate edge to get this and this line here. Hide the form itself, and let's just see. Oh, I need one more. Duplicate edge. Need this line as well. Now let's hide it. Hide that. And now let's just clean it up to get a proper cutter. So I will use fillet with radius of 0 to keep the corner sharp. Like that, like that, like that. Join everything up. And use planar surface on it. Okay. And now let's show selected. Show this guy. Take this one. Extrude surface. So I'll just extrude it to make it, you know, a closed polysurface, and then use Boolean difference to just cut. There we go. So we end up with this kind of cut here. Show selected again. Mirror 0. Okay, so now these two are not intersecting. There's this gear here. We will be doing something with it, I believe. We have this this eye here that we can make quite cool. Let's see the robot. It's cool, and these guys are now removable. Yeah, that's perfect. So probably nothing, you know, you probably haven't noticed anything super fancy or anything like that, because right now I'm just doing really simple, you know, really simple stuff. But as we move forward, it's going to get cooler and cooler, right? Fancier and fancier. At least I hope so. So, but for now, as a first pass, can we do a bit better chamfer? 0.8, like a stronger chamfer. Yeah, that's nice. As a first pass, I consider this fine. Will you chamfer? You kind of chamfer, but you don't look that great. Should I keep you? Let's go for Arctic view just to check. Yeah, it seems to be clean, so I'll keep it. Let's just see here. Chamfer edge. Ooh, that's a broken chamfer there. 0.4. If a chamfer breaks, that means it's usually too large. Yeah, that seems a little bit better. I'll actually place it here as well. Just like that. Seems to be okay. Back to shaded view. Hide all of that. Actually, I really want to chamfer this one. Chamfer edge. Just to get rid of that. Or actually, do we want to chamfer it? Maybe we'll leave it as it is and make some adjustments to it. Okay, so this is going to be the last thing that I do. I will just, or rather, yeah, I will do it. So last thing, and then we will end the tutorial for now. Of course, we will come back to it in a few days and continue working on this. I will just use extract surface, get rid of that. And I will use extract surface on this, get rid of that, so that we have, we can work in between these two surfaces. I'll use duplicate edge to get this edge here and this edge here, these two edges. Actually, let me type in isolate, so I will just be working between these two. How do we want to do this? So for this guy here, I will use offset. I'll say 0.6 is fine, and then 1 millimeter offset here, and then a planar surface. So planar surface between these two rings and planar surface between these two rings, like that. And for these two guys, perhaps I just do extrude curve, extrude it inwards by 1 millimeter, like that. And then let me actually join everything up. Join, duplicate edge, that and that, and I just create planar surface between those two edges, like so. Just to get that small rail there. And now I can use chamfer again. I really like using chamfer because it, not because it of the complexity that it creates, like visual complexity, but rather 3D printers don't like sharp corners. So when you do chamfer, you kind of mitigate that 90-degree corner, you cut it in half, so you have 45-degree corners, right? So there is a benefit why I'm using chamfer so much. Let me take that, mirror it, 0. Come on. Jesus, mirror. There we go. So now it's on both sides. Zoom selected. Join it up. Show selected. Show it all. Oh shit, I forgot hide. I forgot that these guys are disconnected from the sphere. Join it up. Show selected now. Okay. So for now, that's what we have, and we have a little bit of detail showing up, which is cool. And then if I were to decide not to add those two bulky boys there, it would look like that, which is also kind of nice. Okay, so I think we have a nice starting point. In the next video, I'm going to revisit this and see how I can... Yeah, I'm still not happy with this portion right here, so I'll be fixing that. And we will be looking into how we can actually anchor this to the robot. And once we figure that one out, I will start printing test pieces and actually trying to attach it to the robot. But for now, let me actually do this. Emap. There we go. Turntable. There we go. So for now, this is what we have, and I'll see you all on Tuesday, I guess, somewhere closer, sometime closer than our usual Sunday, Wednesday sessions. Where we're going to kind of continue working on this. Hope you've learned something new in this very basic tutorial, and I'll see you with more advanced stuff later. Bye!